Emergency Services. I'm the State Cybersecurity Coordinator. I've been participating with Mr. McNally over here, who's you're the Northern Sacramento Region Cyber Patriot Coordinator. Is that the title?
I like the title. Yeah, I'll take it.
Well, welcome to Cal OES. For those of you who aren't familiar with what Cal OES does, we are the emergency management facility or department for the state of California, which means all of the fires that are taking place, earthquakes, any kind of catastrophic health or hazardous incidents that take place, as well as coordinating law enforcement. We do all that from this area here. We do have regional emergency operations centers located around the state. Through those doors is what we call the State Operations Center. Please do not try and get in there. We have law enforcement officers working around the clock here, responding to events that are currently taking place and trying to quell basically the disaster that's taking place because of the California fires. All right, so they're very busy here. Just some coordinating instructions real quick. If you could please just be respectful of the facilities. I want to go ahead and be able to host this for you guys whenever you guys want to come in and do lectures like these. It's fantastic to have Mr. David Bishop down here to go ahead and run you through some of these projects for the competition. Hopefully that'll give you a leg up and you can make California the leader for the nation. As we move throughout the night, feel free to go ahead and get up and use the restroom. The restroom is in the hallway directly behind me if you haven't seen it already when you were coming in. Those of you who have already explored the facilities. And again, thank you for being here and welcome. So right now I'll turn it over to Dave.
Great, thank you. Got it, thanks. No singing tonight. What a good crowd. Thanks so much for coming. This is awesome turnout for the first regional training venue that we've been wrestling around talking about for a while now, and it's finally come together thanks to Justin and Coach McNally. So tonight, I don't want to wet your whistle. We got 60 minutes to mess around with some techno stuff, but I want to get some feedback from you guys to determine where you are, so we can tailor this training to your needs. This is not the basic 1 through 8 chapters that Cyber Patriot put out. It's going to be a little bit more advanced than that. One of the things that has come up, at least last year, I think the initiated was networking and network-related issues in the Cyber Patriot competition. So we're going to play around a little bit with networking and Packet Tracer. Last year we had a challenge using Packet Tracer, and I'm going to ask you guys to tell me a little bit about your experience with that. But first, I would like you guys to identify a spokesperson for your school. Like, so if there's more than one team here, no coaches involved here, no coaches, no mentors, you guys figure it out on your own. Just a spokesperson for your school, so you can answer, instead of everybody answering once or twice, you can tell me a little bit about your school and answer the questions that I have coming up. Okay, so by a show of hands, just kids here, not just Cyber Patriot practitioners, no techno people on this one. Let's try on a scope of 1 to 10, 10 being a networking guru, and 5 being a pretty darn good networking guru, and 1 being, yeah, I've addressed a computer before. So kids, show me a show of hands for somewhere between 5 and 10, if that's where you fit in terms of IPv4 or any networking addressing skills. Okay, so we got a couple immodest folks here. Okay, good. So 10 being, you guys being pretty dialed in with IPv4. Good. Okay. How about from 1 to 5? Okay. Anyone not know what networking addressing schema is? Okay. Good. Thanks for your honesty back there. Sorry, I won't point you out. Okay, how about subnetting? So we just talking about the overall schema. That 5 to 10 segment again. Are you comfortable with subnetting? Figuring out subnetting. Okay. Has anyone ever done subnetting before, like in Packet Tracer? How about a show of hands for everyone who has used packet tracing? Okay. Now, in that set of hands, how many feel comfortable using packet tracing? Excellent. So we're on the right track. You needed to know that. So tonight we're going to, I should probably tell you a little bit about me. Some of you know me. I did about 30 years as a police guy in California here, up in the foothills. My ancillary duties as a police guy were forensics, cyber forensics. So I was a forensic analyst, I guess, you know, for a local police department. After leaving the police department, I worked for a group called the Search Group. It's a grant-funded organization that trains state, local, and federal law enforcement in cyber-related investigations. And then since then, I have a team of folks that do primarily pen testing for corporate environments. So, Justin, any chance of getting a glass of water?
I think I can finagle something.
Thanks. That'd be awesome. Okay, so that's a little bit about me. Coach McNally, by the way, has brought this together for those of you who don't know him. And then Justin opened up for us, and Justin and his boss was gracious enough to let us come in and use this. Not just tonight, but for, what, 4 months so far?
For as long as we can keep it going.
Right on.
Yeah.
That's awesome. So, I would like you guys thinking about what sort of skills you think would be important for you to learn so that we can tailor those trainings, upcoming trainings, to your needs, not to what we think you need, because tonight I was just kind of shooting in the dark and hoping that this kind of fits. So tonight we'll go over a little bit of IPv4 addressing schema. And we'll dive into Packet Tracer and take a look at the President's Day competition. You guys remember that President's Day competition? That was a pretty good Packet Tracer challenge.
Mm-hmm.
You're a good man. And then we'll come back around after a little bit of Packet Tracer and talk about subnetting, how subnetting works and why we need it, how to do it, and take some of the mystery out of it. Obviously, we're not going to dive in it and conquer it tonight because we don't have enough time. We have 60 minutes to do this whole thing. We've burned up quite a bit out already. So we'll kind of plant the seed, let you guys fool around with it a little bit, and then we'll maybe next training or something in the near future dive into subnetting so you get a handle on it, because it's an essential part of your sub-pager competition now that they're including it in Packet Tracer, or including Packet Tracer at all into your competitions. Okay. IPv4. Computers have to talk to each other, right? So they have to have addresses to know where to send their packets and frames and data back and forth. And so in order for it to get to the right location, we need to give it an address. Any questions, by the way, before we take off? Yes?
Is Packet Tracer in the middle school competition too?
No.
Not this year? Is it? Yeah. Was it last year?
Packet Tracer was seen at the platinum level. It was not part of the gold or the silver for the high school. It was?
Yeah.
For the regional or for the state?
For regional.
For the regional.
Did they? Yeah, it was a state too.
State too.
It was for middle school too.
I think they said this year it was not in middle school.
So
Every year they ramp it up and increase the level of difficulty. So whatever they did last year, expect it the same level of difficulty, if not more, this year.
So if you're a middle school only person, it's awesome you're here because they're going to have your troops will have a head start when they hit the high school range. I mean, if this is knocked out of the way at that level, they'll be miles ahead. I know that up in Nevada City we've got a handful of guys that are just devouring a packet tracer while subnetting, and they're actually sick and tired of hearing me talk about subnetting, but you know, it's giving them a great head start to the next phase in the high school competition. So it's an essential piece of this industry, let alone being a security practitioner. So we're glad you're here, middle schoolers. Hang out. It'll be good stuff to learn. So getting back to IPv4 addressing schema, there are classes. There are 5 classes of addressing schema in IPv4, A, B, C, D, and E. So we pretty much live in A, B, and C. I was going to have a whiteboard, but we didn't actually get a chance to get the whiteboard, so I'm going to try to use, I'm going to try to cut and paste this stuff over. Excellent. So IPv4 is made up of an addressing, 32-bit addressing schema. You have 4 segments of 8-bit octets, they call them octets, or 8-bit segments that make up a range of the address for a computer, for an internet or network range. And as you can see by, did everyone see that all right? All the way up to the top, let me pull it down toward the middle there. Class A begins at 1.0.0.0, and it goes all the way up to 126.0.0.0. Class B, 128 to 191. And then Class C is usually what you see on your routers when you buy them from, you know, like a Linksys router or something you buy from Target or something that will come pre-configured with default Class C address at 192.168.0.1 or something in that range. So that's a pretty common and may look familiar to you. Class D is reserved for multicast. That's something that you will probably see in terms of the competition. And Class E is reserved for research, development, and what's the other term they use? But it's not a range of addresses that we would actually use in functioning networks. So in those ranges of IP addresses, from Class A number 1 all the way to the top end of Class C, there are addresses set aside or reserved specifically for private addressing. So IPv4 addresses that are publicly routable out on the internet wouldn't necessarily be used on your local network inside, and those are called private addresses. And they're not routable out on the internet by any routers that are out in the wild, but they're routable on your LAN side. Those segments are set aside, and they are the second segment here. Can you see where it says 10.0.0? Those Class A, B, and C segments between those two numbers on either side there, so the 10 series, the 172, and the 192 series, are private IP addresses, and they allow you to do whatever you want with them. They won't conflict out on the internet, and they're not routable out on the internet, so you won't see them out there. Usually you'll NAT those or use network address translation to get those to talk to the internet going outbound. Okay, so these will be on a local LAN side on a computer, and your router will have a publicly routed IP address, whether it's dynamically provided to you or statically configured in your router. That's the address that communicates with the internet, and then that device will translate that request going through it to the non-routable private addresses, what your computer will have. Typically, they'll be handed out dynamically. How many understand the difference between dynamic and static hosting? Anyone not understand that? Okay. So, thanks, Sean. When we have networks that are low maintenance, like at home, hey, thanks, Sean, or Justin. When we have addresses that are low maintenance or networks that are low maintenance at home, we typically have them, our addresses for all our computers handed out to us dynamically. In other words, they're not hard configured by the individuals using it. They're given to the computers that come online in that network dynamically. And they have a lease time and they live for a period of time and then they are released or handed off to another device or but it's kind of like autopilot, they're handed out. So that would be dynamically hosted numbers, and then statically hosted numbers would be ones that you would configure yourself. It's important to understand both concepts. It's important to be able to design a network with static IP addresses in it so that you can understand what's happening. Not only is it an industry requirement, but so you can understand more what's happening in packet tracing, because the President's Day competition had a great deal of static addresses that you had to troubleshoot and figure out why your network segment wasn't, there was no data going through that point. Okay, so any questions so far about the classes on addressing? Understand it's an address that one computer sends. It's kind of like your mail address, right? So you write a letter, put an address on it to your grandma, you put your address, return address, so she knows where it came from, send it in the mail, it goes to her house, right? Same thing, same kind of addressing. It's numeric and it's 32-bit. Now, IPv6 is going to be a whole different story. It's 128-bit configuration, not 32-bit, so it gives us a lot more latitude on what we can do with those addresses. We can actually throw them out in the wild and have the wild come right into our lands. And from an investigative standpoint, it's pretty handy because we can identify a lot of machines that wouldn't necessarily be identifiable when we're doing investigations. So let me jump over into Packet Tracer now. And thank you. Okay, so this is the narrative that we got with Packet Tracer last year on the President's Day competition. And I kind of screenshotted it and took a copy of it. I have it available and then kind of mimicked what I could do with it in Packet Tracer to recreate it so that we could use it as an example. But basically, Cyber Patriot created a network, actually pretty complex enterprise with multiple locations. It was supposed to be the White House and Camp David and some other locations of the Capitol building, and the communication wasn't working correctly as they had configured it. So in terms of routers, they had routers in these 3 locations that needed to be configured. You guys can see that, right? Mm-hmm. Okay. They had some switches out there. Everyone know what a switch is? Anyone not know what a switch is? Okay, so, thanks, Coach. There's networking devices, right, that handle all of our computers that come together, right? Simplest one is a hub. They call them a dump device because it really doesn't, it just rebroadcasts all your data that you send. So you get, it's got no collision domain. It doesn't care about packets hitting each other. It doesn't care about sending to anyone specifically. It's just a dump device that moves data all over the place. So you get a lot of traffic on your wire and collisions and not very smooth communication. Then a switch would be a similar type device where you plug a bunch of nodes off your network into it. And it provides a unique collision domain for each device that's out there and allows that wire frame as a segment of data that's moving. It'll have a destination for it. It will also have an address where it's from, so that it can respond back to it and confirm where the packet came from. It's called TCP/IP is a stateful addressing schema, and it takes into account, it confirms, it validates the path of the packet or the frame, and confirms that the addressee gets it, and will also resend packets if it doesn't get it, and it puts them in the right order and that sort of thing. So that happens in a switched environment. And then routers connect to similar networks. So if we have a Class A 10 schema network address scheme on a network and a 192 address or a public routed address out in the wild, a router will connect those two networks for you. Okay, so that gives you a little idea what the devices are out on a network. So your job was to configure those switches that were in this enterprise. Looks like Camp David and Capitol Core switch. The White House had a switch, a couple switches. First Lady had a computer up here on the network. So you were responsible for getting all these things to talk with the appropriate segmentation so other folks couldn't talk, cross-talk, or have privilege to that information that they wouldn't have a privilege to. So that's what was the goal. Show me hands, who didn't do President's Day Challenge? Okay. Who was successful by a show of hands of you think reasonably successful that did do the present day challenge, packet tracer? Did you guys do well? How far did you get? Just give me an idea.
We just have the basic layout. We didn't actually get it right.
You got some things to turn green?
There you go. Very good. Right on.
Yeah, you got about halfway through.
All right, well, let's see if we can turn some things green here. Besides the speaker, right? We'll open up Packet Tracer and the President's Day clone, for those of you who are paying attention. And this is the example when you first open it up, for those of you who haven't seen it. When you first open it up, there's the network, or networks, and then this on the right-hand side here is the challenge that you need to read down through. And I think you guys have learned at this point, read all the way through the end, right? First, make notes, come on back again and read again. Right, okay, so it always challenged us when we had discarded, deleted, gotten rid of something that we really wish we hadn't. I think they have planned that. Okay, so when you open this up, you think, well, there's the network. That's it. We should dive in right here. But I would encourage you guys to become familiar with the whole layout before you spend time. I will provide a link, a download link, for those of you who don't have Packet Tracer. You can get it in many locations. You may as well get it from Cisco Direct, so that's where I got it. You can have it under the Cyber Patriot program, so I don't really feel uneasy about sharing one that I downloaded. It's up on Dropbox, so we don't have to do anything weird. Just give you a link. If I have your email address or Sean has it, we'll send them out. You guys just download it from Dropbox. So there are different versions. Before I get ahead of myself here, there's different versions of it. There's an instructor version, and then there's a student version. Okay, the instructor version's got a whole bunch of bells and whistles on it. The student version allows the instructor version to do set up tests and document and follow along how you performed in the instructor version or the student version. They also come with tutorials attached to it. And I'm pretty sure this is the version with tutorials. You can see the help menu here that I'm pulling down. So the help menu has tutorials. Those come, in some cases, come attached or wrapped up, wrapped together with the application, and some they're detached, so you can get just the application or the tutorials. And so the tutorials actually go through all the elements, which is really handy deal. So that's in the help menu. When you get this, go ahead and check that out as you learn it. So when you first start out, there was a physical layout to the networks that have been included. They have to be created when you create the network, but there's a physical layout of the networks. And if you hit the navigation, you'll get a window that allows you to, let me see a show of hands of how many found this part and used it. Anybody see that? Mm-hmm. Okay, so instead of diving in right into the topology of the network, go over to the physical side, and you can see where all of the devices have been placed on the network. And then you can actually go to, if you highlight one, follow along here. If you're not following me, let me know and I'll back up. You can jump to that selected location. So we'll select the standard, what's this going to say here? There are PC4 in the Senate chamber. We'll highlight it and jump to that location. And it brings it up, a visual of that location. It happens to have a little rack on it here with like a 2960 or something. A little switch, right? It's like there's a PC here. And another PC. Okay, so that shows you the whole location. And we opened PC4, right? That's what we asked it to see. But it looks like there's several PCs in that chamber, in the Senate chamber. So if you tap on these, you can actually go into configuring them. When we get down the road ways, we can dive into command line programming and setting up Cisco switches with the Cisco command line or the iOS command line. Don't get confused with iOS in the Cisco world and iOS in the Apple world. iOS is the iDevice operating system. iOS is Cisco, one of Cisco's operating systems for their switches and routers. So it's a pretty handy tool to use. It gives you a lot more flexibility to program and set up a router, but you can also configure it through a web portal. So this is a 24-port switch. You can see this is a switch here. It's got all the interfaces, and fast Ethernet is the 10100, right? It's not gigabit, it's 10100. Ethernet being 10 megabit. So all of those ports are right there for you to configure. You can jump over there and configure those. So for example, you had a red light on, remember we talked about you getting green lights? You got a red light from the switch. You can go to that port and locate that particular segment of the network and find out why you're not getting a green light. You can look at it here instead of just poking around and guessing what's wrong with it. You can look at it physically also with Packet Tracer. Computers are pretty snazzy. We can pull them up and actually install components. So all of these are modules, networking modules. Oh, here's a microphone and a headset, a camera that you can install into the computer. A little camera, right? It used to be camera. And you install that and configure it in the computer. And all this stuff functions in Packet Tracer. You hit runtime and it goes. It's an amazing virtual tool. So let me back out of that by either hitting back, and it shows you all, see all these little stacked like cards, all the locations that are in that physical layer. Navigation gives us that window back up again, and then if we hit the topology, we come back to a visual representation of those networks to get them going. So you can also tap on them from here and get an idea of what they look like. If you hover over them, it gives you the configuration, and you get it red on both sides of this router here. If you hover over it, you can see that both segments are not connected, right? So both the networking modules, WICs they call them, are not configured, and that's why you get red lights on that. There are a lot of details to go into with Packet Tracer. Just wanted to give you a high view of this, but it's a very cool tool. When you get it, play with it. Can't break it. This version here um, actually communicates with, it's configured to talk back to Cyber Patriot. And that's why the little red X is over there on the networking. So yours won't, so you can open it up and configure it however you want and play with it and get a better understanding of networking. It's his desire to make this whole region a contender across the nation. So that takes, this is a really cool control panel if you guys ever seen this. This is very cool. It's like a spaceship enterprise.
We also have the October 24th practice round competition that you can register for. Have you gotten those links from me? And then we're also working on a California State competition that's going to happen between LA Unified, San Diego, and us. So those are things up and coming. But the October 24th is the most close coming towards us. So if that's something that you want to do.
Competition, right?
Yeah.
So it's our goal to make sure that you have everything you need, whether it's instruction, advice, bad advice, good advice, to get your program set up and running and successful both technically and from a resources standpoint. So before we get out of here tonight, we're going to be asking for some of the things that you might need or want. It sounds like already that we could probably do one of these sessions or more than one of these sessions, which is coaches and or mentors. Mentors I'm sure know their stuff, but they don't know their stuff as it relates to Cyber Patriot. So some of us who are here have created the wheel. There's no sense in recreating it. So we can share with you what we've learned and what not to do and what was successful. So during break, there were a couple of questions about Packet Tracer. So I'm going to clear that up right now. If Sean has your email address, student, mentor, coach, doesn't matter, as long as you're a Cyber Patriot participant. If Sean has your email address and you have no objection that I have it as a mentor, then I will send to you a series of links in one email, and those links will be for Dropbox. And you can choose to download one or all of those instances of the Packet Tracer. Not that one, because that's already created and it's quasi-proprietary. So, blank versions of the program, any version of the program, as long as it's the student version. Instructors and mentors and coaches have access to Net Academy, the Cisco learning environment, CMS, so they can go in and download it themselves. The instructor version, which has more bells and whistles to it. So it's available to you, and the next question is, what really is it? Well, it is a virtual instance of networking environments. So you can create a very small to a very large networking environment, from your home Soho type environment to an entire enterprise like this White House program that they put together, which is fairly elaborate. It's got a bunch of different communication media in there and forms of moving data around. So it's a fairly complex environment. Pretty neat, actually. And it's virtual, so you can't break anything. I mean, if you break it, you just start over. It doesn't cost you anything to break it. And that's what it's all about, is to learn and get in there and mess with it and figure out why you broke it and see if you can fix it after you broke it. And if not, start over, right? It's the greatest learning tool out there. I mean, it's fabulous. So just like the virtual images we use to compete, right? We use VMware, and we have an image that we bring in, and it's a virtual instance of an operating system that's running. Well, this is a virtual instance of a network that runs, and it actually is functional. I mean, it actually will move data. I mean, it actually has services that run on servers, so you can set up a SMTP or SNMP services on your on a server in this environment. And if it breaks, you start new. And it's a great way to learn. So that was the other question: is what the heck is it? It's your opportunity to learn how to address and set up networks. Not just address, but how to engineer and design a network. with a myriad of different tools, like old school FIDI to current and contemporary fiber-related modules to configure and get networks talking at various speeds. And so it will tell you if it's working. There's a button down here that says fast forward time. I don't know if you can see that little button there. That will cause things to configure periodically to figure at that point, specifically when you click that button. So if it, for example, handing out dynamic addresses on a particular period of time, it will do it as soon as you click that. So it speeds up your awareness of whether or not the network's working. So I'm going to, Coach McNally asked me if we could go ahead and create a little network here. And we can. We're going to do that right now, actually. No one's opposed to it. And before we do that, I would like you guys to think about, write down questions or desires that we can take with us and prepare for the upcoming meetings. So from a coach's or mentor standpoint, or from a coach's standpoint for their mentors, whatever it is, write down a question so that we can tailor this program to better suit your needs. Was there another question unrelated to that? Okay, here we go. We'll create a new little network here. So this packet tracer, we can create an instance right over the top of this, or we can dump it and just start new. We're not going to save what we did to it. Hit the instructor's version of packet tracer. You get a little splash screen there, tells you what it is. And when it comes up, you get this blank slate to work from. Remember, there's a physical side back here. You can actually put a picture in here. I think there are pictures in here. Set the background, you can put a picture of your neighborhood right there. So, if you want to point out particular buildings on your campus, that's, if it's an academic environment or enterprise environment, you can point out where these things are located. You have a little pop-out map there that describes where those devices are. So from a network standpoint, we'll go ahead and add devices. There are a category of devices in the lower left here. And as you hover over the top of those little icons, that gives you an idea of what those devices are. So if I hover over this lightning bolt, it says connections. If I click on the connections, I will get a segment. Oh, by the way, before I forget, they have this in iDevice for your iPhone and iPad. It's pretty cool. So if you hover over and select that, it changes into the devices. This window to the right of that changes into the available connectivity medium. So you get crossover cables, straight through cables, fiber cables, terminal cables. Did I say crossover? There's all the potential cables that you could, I don't think they have a null modem, but you could probably program your own in there. So those are the cables that you would use, the medium between device to device, right? So then you hover over here, wireless devices. It's got a handful of particular, it even has a cell tower, in case you want to do your own cell enterprise. Hubs, right? In case you have an arcade hub environment or you want to set one up to see why they're so dangerous. Switches, get a myriad of course, Cisco switches, and then even a generic switch. Classic Cisco 2950 switch here, 24-point port. And you can change the names on these things. Once you pull them out on your canvas there, you can change it and label it for your particular network, my switch. So this round icon over here is a router. It's a kind of industry standard that signifies an icon that signifies a router. There's a little 18 or 1901 router. These are little desktop routers that handle a couple of wicks that go in the back. Those would be the modules that adapt to the INPO from the telco. So if you have like a DSL modem or a T1, point-to-point T1 circuit, you would put that particular wick in the back of this little device here. And if we click on it, you can actually see, look, come on back, the physical side of what it looks like. And you can drive through here and find the right wick that you want. Let's see, here's a, trying to find a fast Ethernet one. Here, we'll just put the T wick in it. And if it doesn't, this is how detailed this is. What's it say? Can't add the module when power is on. Seriously. So you have to turn the power off. And then you can add your T to it. Come on there. We're back up the wrong slide. There you go. So then you put your wick in there, then you turn it back on, and it lights up. So that's how you would configure that particular device. So let's see, end devices again, servers. Security would be, what would security be? Anybody? What would security be? What do you think it'd be?
Firewall.
Hey, firewall would be good. Yeah, good idea. Firewall. Of course, it's a Cisco firewall, right? Custom-made devices. Haven't played that yet. Okay. Multi-user connections. So what would a multi-user connection be, you think? Skip, what would we put you on the spot. What do you think they were talking about when they say a multi-user connection?
Me outside?
Hmm?
Yeah, they're talking about peer-to-peer connections?
Yeah, a peer-to-peer connection. So you get multiple users on the same segment, same network, and you tie them all together so you can swap files direct to direct. Right? It's like having a big network. It's all yours, whether it's in the same location or not. Typically not. End devices would be, what are end devices? Come on, Lucy Burbank. What are end devices? Anything on the end, right? Yeah. Computers, there's a PC. Let's select it over here. And see, they got a phone and TV, a smart device, a sniffer. Very cool. So, what do you think a sniffer does, anyway? What does that do?
That's good, right?
Right? What's a sniffer do? So if you're a network engineer or a security practitioner, you got a sniffer on your network, so you could see maybe somebody doing something inappropriate, or if you can see if your network's clean, if the packets are moving moving swiftly. You know what I mean. Okay, so those are all the elements, right? So let's try to tie a couple of them together here with some wires. I didn't even think about what I threw out there, so let's see if we can make it work. So this looks like a computer, and it's got a module. That's not a wire. Let's just put there's a network module up. I didn't turn it off, did I? Okay. How do you turn them off?
You have to click on the desktop tab.
No, I hit the little button, so it turned, the little green light turned off.
Okay.
Put a module in here. And we can configure that module, we'll turn it back on. Settings. So we can ask it to get its IP address, remember its address that we talked to? We can get it dynamically if we have a server that's going to hand those out, like a router or an actual file server or web server. Or we can program in the address ourselves. We don't have the gateway set up yet, so let's go this way. Here's the interface itself. So we're going to put in an IP address. Subnet mask tries to give us one that we're not going to use. That one looks pretty good. Okay, we're going to static address. We're going to come on over here to our gateway. And somebody remember what this is because I'll probably forget. Whoops. And I'll let that serve up a DNS also. What's DNS? Somebody?
Denial of service?
Download.
What did you say?
DNS.
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 Uh,
Come on, somebody, DNS. Come on.
What was it?
Somebody said, come on. No.
Okay, let me help you out. It's domain, okay, domain name service. So the DNS translates those numbers, those 32-bit octet number address into a name. So we can put google.com and it goes out to 8.8.8 or one of their other many servers, okay? So the switch we're going to set up to, we better put a module in it. Actually, let's see if this thing will
It's
automatically.
already got 20 ports in it, so it doesn't require a module.
What's that?
Oh, I said it's already got ports in it, so it shouldn't require a module.
So what are we going to use? No, not that one. Let's use a copper straight through. Go from here. Oops, better. You see when you click on it, you can hook the RS-232 port, or you can hook the Ethernet port. Which one do you think we ought to use? If we're connecting for network data on a network, which one are we going to use? Ethernet? Probably. Okay, let's do that. And we'll tie it in over here to the first port. Green on one end. Is that green, you guys?
It's orange.
Orange, what's that mean?
Bounce it up.
Oh, where'd it go?
Oh.
It's here. Okay, and then so we're going to connect this out to this little cloud here. It's in loopback mode. We'll go straight through. Yeah, straight through will work. So connect the other end of it out to this cloud. Oh, that won't work on that. You got to get it in. Here we need to get this little guy over here. That's Ethernet. This one, the cloud. So we're not going to leave we'll leave the cell tower right there. Looks good right there. And we'll get rid of this router. Delete. Big X. And we should probably put a firewall in. What do you guys think? Firewall or no? Well, we already passed the firewall, so. Anywho, we'll leave the sniffer out of it too for the time being. We'll let you guys fool with that because it's actually give you traffic. Show you the traffic cruising through. That particular sniffer or that particular device will show you traffic that's going through.
Where did you find the slipper?
It was under, I think, other devices. Hold on, don't go anywhere.
Undo.
Undo, thanks. Good job, Justin. God, maybe you guys should drive this thing around. Get rid of this thing. Or do that again. Okay, so let's see. Let's configure this thing. Did we put it? We did put that in there, didn't we? Okay, so we got that configured. That's our gateway. And did we configure this guy? Oh, it's set up for VLAN, right? Okay, Mr. McNally.
Yeah.
You want to come configure this for me?
Me?
Yeah, because I'm working on it.
I got 10 seconds before I have to hit a button again right here.
Check under settings.
Okay, now I'm free for 20 minutes.
20 minutes? I was just kidding to have you set this up. Really was. You would?
I'm just watching. I'd like to learn something.
All right, well, we'll keep on moving on before everyone falls asleep. So
Okay.
anyhow, you get the general idea of how it goes.
It's green.
What's that?
It was green.
You had a green light?
Did I get a green light?
See, you got green.
And it was in the same setting too, so it needed to be just like, so, it's interesting that it throws a radius of where the location is out there for you automatically in the physical aspect of it. And you see our rack, it's in a rack for us, main wiring closet. You jump to that location and there's our router and our switch. They put it in a rack for us, same location. So, that's a general idea how it works. You can create all kinds of different networks, much more complex than just end-to-end. And then you can watch the data for it. Let's see if we can do. So this will allow you to, all right, outside the scope of my preparation for tonight. So let's see, this will actually show a log of the data that goes through. Okay, here we go. The data that travels through those segments that you highlighted. So you can watch implementing spanning tree protocol over, you see in the top right. So it's in there traveling, bouncing back and forth. Goes from my switch to the PC and from the PC to my switch and back and forth. So you can track your data and find out where it stops and where it falls off, where's your hang up on it. Like this is going back and forth between these, but not going to the router over here. We didn't fool with that configuration. All right, does that give everybody an idea? General idea what it looks like? Okay. No more boring?
So these numbers that you're choosing, how do you go about choosing those numbers?
That's the whole learning process. So anyhow, I just keep creating a very simple Class A network here that is got 254 nodes on the network and just making them talk to each other. That's it. So very simple. That happens to be the addressing schema that we talk to each other. So you could do network segmentation here and have on different layers for security purposes. You can. We had a question the other day. Why would you use subnet masking? Right. So you mask out a segment of your network, so you keep different. Only allow a certain number of machines per segment. Right. So there's no room for an intruder to come in. There's no space for them to come in and be on that network and capture data if they don't have permission to be on it. There's all kinds of reasons. We can get in that kind of a deeper level. This was a kind of a high level pass through and give you an idea what it was about. So, was there another question? Someone right there?
Just curious, when the mail comes down, it's getting a red X on it. Does that mean it's deleted, or does that have a meaning to it, or?
I haven't a clue. That's a good question, Tom.
I don't, just curious.
I don't. You know what? I don't know, what that is. You could probably look at one of the,
That's okay.
yeah, it's not a clue. If it's not green, it's not cool.
Yeah.
Could fix it.
It's a green check.
This is a good thing about it, is troubleshooting, you know, when we understand what the X means, we can realize that, oh, that's why it doesn't all work. Instead of just going back and reconfiguring it all correctly, we might be able to just do a little tweak instead of reconfiguring the whole thing. So, yeah, I don't know what the red X
It's either
is.
not
Maybe
getting
it deletes.
through or it's being deleted, I guess.
Do you know what it is when it hits the bottom? Gets the red X? Okay, so, did we do the post-it thing? Sean?
No, I did not get that set up for tonight. I think that's going to be a good tool for next time.
How do you want to address that? Just by taking questions?
Yeah, we're doing Q&A. So who's got a question on the floor if that's what you're ready for? Or we can keep going with what you got.
How about you guys come up with, for us, things that are important for you as coaches, as students? What do you want to learn?
In this forum, in a room like this, what would you like us to bring to you in this lecture series? And I'm going to write some things down on the board. How's that? Marker.
You kind of touched on a good point just a second ago. If you were going to secure this network, a subnet masking, how would you do it exactly? So that everybody really understands what all is entailed there.
Okay. I wish we had more of a whiteboard to do this. It's so much easier than up there, because I think everyone's going to get bored if I kind of muddle along here. But subnetting a network is a process by which we make a determination of that network address, how much of that network address belongs to a network, and how much of it is room or space for nodes on that network,
Right.
or computers, right?
Okay.
So in that network, this subnet mask that I used, it's at 255.255.255/0. It's a /8 or a CIDR notation for /8 network. I mean, there's only 254 potential addresses on that network. So I can only have 254 computers on it, which is a lot of room for someone to sneak in on it, right?
Right.
So if we use CIDR notation and we crank that up to, say, a 224 on that last octet, 254, that reduces the number of nodes that can be on the network. So if you have a network that handles, say, a router that's connecting dissimilar networks. So in your enterprise, you got finance and you've got HR. They do share information, but they have their own networks. They need to talk to each other, so we put a router for each one of them. And they connect each of those networks. If I only have four total, but two potential addresses on that network by using the correct subnet mask, then there's no room for anybody else to get in between there and capture the data that's going between it. Okay. They have to knock one off and pretend to be it, and there's going to be alarms and bells that go off and say, hey, you're not the guy we thought you were, right? So you would use a .252 or something, and you would only have two potential addresses up there. The last address being the broadcast address, the first address being the actual description of the whole network itself, and then two nodes on it. So there's no room for, and so you segment in a fashion that doesn't allow for intrusion.
You do that when you're setting up the configuration.
Say it again?
You do that when you're setting up the configuration.
Configuration, right. You probably should do it here on paper first, kind of get a general idea, and then come back into the configuration.
No, I was actually going to use an analogy that might kind of help make it a little bit clearer if you're not used to this concept. And that is, you think of the IP address, for example, as the address of your house. Well, the subnet mask basically would correlate to your zip code. So everything that's inside that zip code, that's within that subnet mask, is local to you. It's in your neighborhood. If it's outside of that area, then you have to mail it. It has to go, it has to go through a router or something to get outside of your network to get to that next address. So it might help you kind of get your head around what the concept is there. And based on what that subnet mask is, it tells you how many houses are in your neighborhood. Okay, so if it's a 255, 255, 255, that means there's around 252 houses, potential houses in your neighborhood that can be built there. If it's a, and so part of subnetting is learning, what those values mean. But basically what it means is that if you have an address in the subnet mask, it compares the address you're going to with that to tell if it's in your neighborhood or if it's across town. And if it's across town, then it goes out to the router and sends it. So just try to, does that help make it a little clear what it's used for? Okay.
Is this, is that too difficult to see up there, the chart, the spreadsheet on the bottom? I know it's hard to see now, but this will give you a little bit of an idea of what this looks like. That's a great question, Tom. Thanks. It's a huge piece. This, can you see that all right? That's an idea. That gives you an idea of what subnetting looks like. Well, the class of the network, A, B, and C we talked about, the bits that are toggled to achieve a particular network segment. This is decimal relation to the binary value. Let's see, it's in the 4th octet on the class C, right? It's all the way up in the 1st octet and the 2nd octet, actually, in the class A. This is a cider notation where we put a slash so we can use fragments of that last octet. So if we have 32-bit, okay, we'll dive in here. This wasn't going to be this deep of a course today, but let's dive into it. What the heck? Okay, so we have 32-bit addressing schema, right? We used to do this over here in Grass Valley. So let's do 255, 255, 255, 255. 1, 2, 3, 4 segments. Each one of these segments is 8 bits, okay? 8-bit segment, 8-bit, 8-bit, 8-bit segment. 255 is the broadcast address, or essentially in a network subnet mask, it passes to the next octet. If this is a 0, that value down here is 0. If this is, let's see how we figure this out. Okay, so each one of these are 8 bits. So if we add 3 of them together, that's a 24-bit subnet mask. So if we had the network address, say 10.0.0.0, describing the network, /24, we would know that that's a subnet mask is 255.255.255.0. Now, if we want a few of the bits out of this last octet, we're going to change that 24 if we do a 26. So at /26, we get 2 of those bits in that last 8-bit octet, right? If we want 4 of the bits, we'll have /28. And it gives us the ability to granularly select the number of bits that we use in that last octet. Why do we want to do that? Because we want to lower the number of nodes that are on the network and increase the number of networks that we can create somewhere else, right? So we can make all kinds of networks for HR and whatever departments you have, special departments and this and that. You have all kinds of networks. And you have networks you won't even use. But we can narrow down the number of potential nodes that are in those networks that we actually do create by using the cider notation. It wasn't very trendy early on. They just used what they call classful subnet masking, and that would be, classful would be full segments of those bits. So it'd be 255, 0, 0, and 0. That's a lot of computers out there. I don't know how many, but it's probably, I don't know, it's over 100,000, I think.
Much more than
I can't tell you how many, but those kind of numbers make me dizzy, so I wouldn't begin to guess at it. But the thing is we can lower the number of computers on our networks and gain more control of who's on the network by changing that last octet. For example, also if you have a cable modem, cable companies is very insecure, by the way. But your cable is just a node on a huge network. And I don't want you guys to ever do this, just believe me that I say, if you jump on the other side of that network, or on that cable modem, you can see like everybody's out there. You're part of this huge network. And their subnet masks are they're configured so you have lots of nodes on their segment. So you end up with 2 zeros on the end, or even 3 zeros on the end. So /8 subnet mask, or /8 CIDR notation on the network. Because there's so many people in that one particular network. They'd rather have a lot of people on less networks, it's easier to manage, than a whole bunch of networks you have to manage because the people are going to deal with their own nodes. I mean, that's their problem, right? Just pay your bill. That's all they care about. So they just want to deal with it. It's easier for them to have less networks. But if we made more networks, you probably couldn't see your neighbors down the street when you step past that router or their cable modem. So, move that? Was that being too quiet?
Yeah.
Okay, I can do this.
The concept, there you go.
Okay, what?
That's good.
Did it work? Did, I mean,
Yeah.
get it? So that's why you would use
That was helpful.
subnet masking to divide whether the size of your network based on the nodes that you'll have on the network for security, for segmentation, and for ease of use or by design. This is the baffler. Tell me I'm wrong, but most practitioners in the industry don't get this stuff because they have calculators now, right? Like when you're in calculus, you can, right? Same thing with IT guys. They got a little machine that makes this all easy for you. But if you guys know it, you can look at that and go, whoa, there's too many nodes on the network. There's a problem here. Or there's not enough nodes on that network. Okay? So knowing it and having an understanding of it is a good thing for you to have. So we'll cruise over that in detail on another occasion that we come together. So it's like 7:52. Do you want to do some more stuff?
Yeah.
You have more questions?
Yeah.
I think everyone's falling asleep at this point. Not that boring, am I?
So what did you come here wanting to go away with that you may have not gotten yet that we can tackle a little bit of right now? Ryan?
It's more about the basics for getting started, since we've never done it before.
Okay, so basics for getting started for your practice round?
Getting ready for competition.
You ready for competition? Well, one of the first things to understand is you're going to have images that you have to fix. You're going to have a Cisco Networking Challenge quiz that's a multiple-choice quiz. And you're going to have to answer questions in regards to the Cisco training modules, which they've been waiting to release.
Not that you need it.
Which they've been waiting to release. Did the email come out today? Because I saw your Patriot email that came out today that looked like it talked about Cisco. Okay, so as coaches, we need to get in there and get access to the new Cisco training modules, make sure that our students get a username and password so the students can log in and get access to the training modules and begin reading through the new training content. Now, I have access to last year's training content, and that's what I've been using until the new stuff came out. The packet tracer is the third item that we need to prepare for. So these competitions now have three things: the image, the Cisco Networking Challenge quiz, and packet tracer. That's what I've been targeting. Yes?
Are the exhibition rounds going to have packet tracer on them?
The exhibition round images have been very simple images, something that we can use as a recruiting tool and just kind of whet the appetite of those people who may have not done this before. Exhibition images are very basic. Introductory image was very basic. I'm hoping the practice round images are more challenging and have more depth to them so we can actually try some of the things that we've been creating. Checklists are very important to have in place when fixing images. The checklists are those things that remind you what to go do. Now, let me just give you a picture here. North Hollywood High School, champions from 2 years ago, had over 17 pages in their checklist. Okay? Grissom High School was number 2 years ago. This past year, their ranks switched. Now Grissom's number 1 and North Hollywood is number 2. And so until we have checklists of 17 pages long, I don't think we're going to be competing at that level yet. But that's what I'm striving for with my teams at Oak Grove High School, is getting to know enough mentors, picking their brains enough to find enough things that we can add to our checklist that would be customized for a Windows 7 operating system, for a Windows 8 operating system, for a Windows Server 2003 operating system. I don't know much about servers. I think